Hey guys, I guess there was some confusion on Dalton's law, so I just want to give you just a brief overview of what Dalton law really means, okay? It's really not that complicated, we just got to break it down. So let's talk about what we've been doing. So up until this point, right, we have been looking at gases individually. We haven't talked about if we mix a gas or any of that, we're just talking about them by themselves. So when we talk about Dalton's law, right, Dalton's law is a way that we can figure out if we combine two gases together, what new properties potentially are going to appear. And then the second question is, what's going to be the total pressure? Because now I've added more gas. So this example up here, in my very first little balloon or bubble or whatever you want to call it, okay, this is my oxygen in red. All right, and what I want you to see is, okay, oxygen by itself obviously is going to exert a pressure on its own, right? And when we talked about this, I want you to think about pressure in terms of molecules of gas hitting the side of the container. So you see these arrows? As these molecules of gas are moving around in the container, as they hit the sides of the container, that is what is creating pressure, right? The same thing goes for our friend nitrogen over here, okay? So when nitrogen is bouncing up against its container, it bounces against the container at a certain rate depending on how many particles are in there. And the more that it hits the sides, obviously the greater the pressure. All right, so each individual system has its own pressure, and it's based on the amount of that particular gas and its collisions against the side of its container, okay? Remember, we talked about this in the very beginning. Kinetic energy, if our molecules are moving faster and hitting the sides of the containers faster, it'll be a higher pressure in that particular system. Okay, what Dalton's law is going to look at, Dalton's law basically says, okay, cool. We're not just dealing with the individual gases, right? Now we have a wonderful mixture of gases. And in this case, what I did is I basically took my nitrogen and my oxygen and I put them together in the same container. Now, the few questions that need to be asked, I've already written them down here at the bottom, is, are there going to be any new properties that develop? Because now I've combined oxygen and nitrogen together. And now I have added gas molecules to a system, right? Which means that they are going to be bouncing against each other more often, which means they're going to be bouncing against the sides of the container more often. So now what does that do to the pressure of a system? Okay, so that's the very first thing that I want you to think about. So the whole point of Dalton's law, and if you looked at the definitions for Dalton's law, and I'm going to simplify it, right? All of the gases that are in a mixture, if you add them all together, will equal the total pressure. Okay, so basically when you see P1, P2, P3, okay, we'll probably never go past P3, but what that means is if there are three gases in the system, one gas will be P1, the other one will be P2, the other one will be P3. Basically, Dalton's law says, hey, if we're all in the same container and we are bouncing up against each other and we're all creating the pressure, then that means each of our individual pressures added up will equal the total of the system, okay? And the reason why that makes sense is because in the same amount of space now, we have more molecules, which means that the collisions are happening more often, both with the other molecules and also the sides of the container, which means that that particular container is going to have a greater pressure than each of the individual containers by themselves, if that makes sense. Okay? So just in a recap, we have oxygen that exerts a certain amount of pressure depending on how often it hits the side of the containers. That would be the pressure of oxygen. Then we have nitrogen that is going to hit the sides of the container at a certain rate. That is going to be the pressure of nitrogen. When I put them together to find out the total pressure, I have to add up the pressure of oxygen plus the pressure of nitrogen to get me the total pressure of the system. And that's why Dalton's law is known as partial pressures. So to figure out the total, it would be the partial pressure of oxygen plus the partial pressure of nitrogen is going to equal the total pressure of the whole system. So hopefully that explanation makes some sense.